Timur Donayev here is with Paques. So I've been working with Paques a lot lately on things like removing H2S from biogas, and Paques has a very interesting new digester technology to bring to you. I've had relationship with Paques for over 25 years now, where they've had a lot of different approaches, very established in the digester space from the Netherlands. So one of the strong brands in our market. So with that, Timur, the show is yours.
Awesome, Paul. I appreciate it. You're running amazing show. I'm very happy to be here. Today, I'll be sharing some information on what I believe is quite an interesting approach to sandbed manure digestion, the technology called CBD, and going over the biogas desulfurization Thiopaq technology. Very happy to be here. I see everyone is trying to be on time. I'll surely try to be on time as well. Paul, if anything glitches, let me know, but it seems like I'm presenting the right screen, so I'll just continue. I'll start with a quick overview of who we are. We will talk about Thiopaq, then we will talk about the CBD, and summary and Q&A, very straightforward. So first of all, who we are, well, my name is Timur Donayev. I'm the General Manager for North America. Right there in top left corner, our headquarters are in Salem, New Hampshire. I actually sit in Philadelphia. But Paques has been in business since 1960s and in anaerobic business since early 80s in a continuously nonstop operational company with multiple representations. It's all started in bulk, the Netherlands. But right now, the regional offices are Netherlands, North America, Latin America, India, China, and Asia Pacific. I think we're over 400 people at this point, all over the world. We started and continue to be a leading anaerobic provider in the high-rate anaerobic space. So in the space of the industrial wastewater treatment, usually using granular technology, is where we started. Since then, we also developed the technologies for biogas desulfurization, nitrogen and phosphorus removal, and the sulfate removal as well. So today we will cover a little bit of offset technologies in the floccular digester space, but biogas desulfurization is quite established for us. The big thing that we pride ourselves on is that Paques innovated and brought to the market every single technology we started. I don't think it's well known overall, but the first high-rate anaerobic digester in the world was Biopack through Latinga. Anamox technology was actually first brought as a commercial technology by Paques as well, but now in the United States, Anamox technology and Anamox bacteria are inseparable. So we're actually having a hard time filing for patent there. And I would say the latest and the best in the biomimicry world was the biogas desulfurization, which I will dive into a little bit. And as you can see, none of this are new for us. We have over 1,500 established high-rate reactors, over 65 Anamox reactors in the world, and 300 plus number is now over 350. I think sometimes we count them by commission, sometimes we count them by installed, so the numbers differ. So the first USB was 1981. First Thiopaq was 1992. First Anamox was 2000. Without a doubt, we're the innovators in all the three spaces, and we're hoping to continue to innovate in those spaces as well. That's actually the entirety of our corporate motto. We provide the full scope solutions. In the United States, we mostly act as the EPC, right? We're providing the technology for the solution to be integrated and overall, and we're happy with the integration of the solution where it matters, and all of the post-market services are provided from this office as well. Let's jump into what the Thiopaq process is. Thiopaq process is a desulfurization process that uses a biomimetic method where the recovery of the caustic that is used for scrubbing is accomplished using naturally occurring microorganisms. They're called alkalinophiles. They're an extremophile subset of microorganisms, very, very robust. They were discovered long time ago. I have an interesting slide about that. But the basic idea is it's a two-stage system. A first stage is your well-known chemical scrubber, except the scrubbing liquor is a biosolution. And then we have a bioreactor where using biological method, we recover sodium hydroxide back into the solution and precipitating the adsorbed sulfur in the form of elemental sulfur, separating it. And that way, the treatment of the H2S occurs in a regular chemisorption method. But the beauty of it is the recovery of the chemistry and the continuous recirculation that allows the operational cost to be substantially lower. So let's see the application ranges. As you can see, the slide is over 325, 53 installations in North America. And I think this year, I count actually with the commission systems, we will add almost 20 more systems to the installation base. And the treated load, and I will talk about it a little bit more. Overall, right now, we're treating almost 300 tons a day of sulfur in the market. I think for this slide, I will go over quite fast over it, but the majority of people on the call know why the H2S needs to be removed. In the context that we usually talk in the RNG market, we're talking about anaerobic digesters. The majority of substrate will bring either sulfur in the form of protein or the sulfate in the form of the sulfate. And then during the anaerobic degradation, it forms the reduced form of the sulfur, which is the sulfide, corrosive, odorous compound. Moreover, if you're going to be flaring anything, you will be under the Title V regulation for the SOx emissions. That's why we prefer to control H2S in a biogas phase for the multitude of reasons. So this is where this technology fits. I think most of the time people ask about the biology here, and the mouthful of the name is the chemolithotrophic halotolerant. Halotolerant just means they can operate at high pH. SOBs, please don't confuse the acronym for anything else, but that's sulfur oxidizing bacteria, completely naturally occurring. If you ever go to Yellowstone and see the beautiful yellowish, greenish formations around the salt hot lakes, that's definitely the SOBs. And the whole
this teamer with all of these different bacteria names.
I would love to quiz people, and if I'm throwing too much of the information, to me those are very near and dear to my heart. All the names, I love them, and we treat them well because they treat us well.
Don't worry, no quiz. Don't worry.
No quiz afterwards. But the basic idea, this naturally occurring microorganisms very easily in a high pH environment take the sulfide in adsorbed form, and if you control it properly, they oxidize it either all the way to sulfate, which is what we don't want to do, or they oxidize it into elemental sulfur, which is what we usually want to do, in which case it's very easy to separate from the slurry. You take it away as solids, as the supplemental solids, and then you recover the caustic that you're using here. And that's what I was talking about here, right? I mean, can you see my mouse? Paul,
yes.
Yeah, okay. So here, as I said, if you're any familiar with wet scrubbers, you would not be surprised by anything in this column. It's a packed free media column with a countercurrent recirculation of sour gas coming on the bottom, the treatment solution recirculating from the top, and in a countercurrent fashion, all we're doing, we're absorbing H2S from the biogas phase into the liquid phase, after which it goes into the bioreactor for the oxidation. And then we have many different methods of separating the sulfur, which will describe in the coming slides. But the only additions that we use here, obviously for the recovery and for oxidation, we're using just your conventional blowers, positive displacement, to supply air into the reactor. And since the bugs, who I love so dearly, and I use their full names in the presentations, do all the work for us, all we're trying to do is trying to keep them happy right here in the reactor. For that purpose, we need a little bit of water because we do need to make sure the conductivity doesn't go above certain point, because if you oversaturate TDS, then you will not be removing anything inside of the scrubber because you will reach the absorption capacity of the liquid. You need caustic, but very little amount of caustic compared to conventional chemical scrubbers because you're constantly regenerating it. But obviously, with the solution being blown out with the sulfur, you do lose a little bit. And then all you need to do is supply micronutrients for these guys, and they're very happy with very, very small amounts of micronutrients. For the majority of installations, we're talking about a couple totes a year. And that's all that happens here. So, and the basic idea is, as I described, sour gas comes in, treated gas comes out, and the bugs do all the work inside of the reactor, where HS minus or H2S, that's the pH dependent relationship, biologically converts to sulfur inside of the reactor.
Where do you see the best fit for this as far as, say, pounds of sulfur per day compared to, say, dry media?
Anything above 80 to 100 pounds. I will describe it. The slide is coming up, but that's definitely
okay.
Paul, excellent question. I will cover it where the sweet part starts. It's a very fair question. There is absolutely I'm an engineer by training, even though I do some general management these days. But every single technology has the sweet spot in the application, and without a doubt, adsorption media has very good application spots. But we definitely see right around 80 to 100 pounds is where the breakdown curve starts happening. At higher loads, there is no doubt that this system is much, much, much more economically feasible. So we use the random media for the adsorption and filling. It's very simple delivery. FRP tank gets delivered to the site, and then you just pour the media inside of it. It's the third-party media that has been validated, and we've been exclusively using the same third-party media, so there is no question about the experience with the specific media for us. The specific reactions, if anyone wants to see, I will not be going too deep. But the specific reaction is very straightforward for the adsorption in this case. The specific reaction in the oxidation phase are a little bit more interesting. So I would like to spend a little bit more time discussing this here. And it's very important to discuss the controls here, because if you remember me talking about the cycle of the sulfur, right? And if you give too much oxygen, it goes into sulfate, in which case you're over-oxidizing and will actually be consuming more chemistry, because sulfate obviously converts to sulfuric acid in water, which is a very strong acid. So the careful control that we're striving for is the oxidation reduction potential inside of the system, which is all automated. It's an automated probe inside of the system that is included on the recirculation loop, in which case we carefully dose the oxygen so we don't go over it. And in the certain range of ORP, exactly what happens is exactly what we want to happen, where the sulfide in the system does not get oxidized fully and stops at elemental sulfur, which is very important in this case. And then the sulfur slurry precipitation and the separation happens. So the multiple ways we do it depending on the load, and Paul has worked through a lot of these iterations with us on the separation of sulfur. Sulfur in and of itself needs to be in the end discharged in the form of either thickened liquor or a cake, depending on the load. Most of the time, if there is a lagoon close by or the treatment or aeration pond, all you will need to do is to send settled slurry directly there. Sometimes people like, especially at the higher end of the loads, with the bigger loads, they prefer to add decanter centrifuges, small skidded systems, so they discharge the dry cake. But we can talk about the applications of the sulfur cake. Actually, if there is close by agricultural communities, a lot of people lately like to discuss taking of the sulfur, because interestingly, and that's a fun factoid I'd like to bring up in public settings, is that after we in the United States applied the Title V for the control of sulfur, we did such a good job that the sulfur in the soil went a little bit deficient lately in the last 10 to 15 years because previously we were concerned about the acid rain, but right now some of the places would actually need some sulfur supplementation because the soil went alkaline. And the biological sulfur is just a cake, right? It's a yellowish cake. High removal efficiencies, we can guarantee less than 25 ppmv on the effluent from the system, regardless of the influent. High reliability will also guarantee the uptime. It could be discussed if the uptime is something very important, over 98 to 99%, no problem, very low operational cost, high biogas utility, and no other dilution streams. We're not diluting with air, not introducing any oxygen. Everything happens only in the biogas phase. When you approach us, we will be asking the questions about the gas flow, H2S load, the turndown requirement, inlet pressure, CO2 concentration, and oxygen concentrations. And then we can provide a quote very, very quick. The budgetary quotes, we come back within 48 hours most of the time. Very robust and reliable, no hazardous byproducts. And as I discussed, the point number 8 here is produced elemental sulfur can be used as a soil fertilizer, which is something I would like to discuss with every single client on the project by project basis. The application ranges are very wide. Majority in the United States are actually in RNG sector, but in the world, we use pulp and paper, food, landfills, digester beverages. By sulfur load, obviously, oil and gas are quite big. But by number of applications, and you can see pulp and paper and food is quite big. For the United States, I would sell that digester, the majority of them are actually in the United States because that's the majority of applications here in North America. And this is where we're coming in. Actually, the smallest load we can do is around 20 pounds a day, but the largest is 20 tons of sulfur a day. I would say the break point, exactly to Paul's question, which was a very good question, I would say the applicability is right around 80 to 100. There sometimes makes sense to install the smaller systems and their package systems in that case, but usually we recommend considering around 80 to 100. Consumables are caustic and nutrients. Utilities are water, power, instrument air, heating and cooling. And the only waste that comes out is the sulfur waste. And obviously the sampling and testing and general equipment maintenance is what you need to put into it, but that goes with any single biogas desulfurization system. We manufacture everything in the United States. Everything could, well, at the very least, everything could be manufactured in the United States. Sometimes we will bring from other places, but we have manufacturing facilities here, FRP in the United States, and the fully skidded system manufactured are manufactured here in the United States. So only thing you need to do, you get a skidder or a container on site, FRP vessels, and only thing you need to do is interconnecting piping on site. Yep. Everything is inside is pre-piped with a control system, HMI, and the SCADA coming to your facility.
Go ahead.
I'll
just add to that. I used to think that maybe this was more on the innovative side of the spectrum, but it really is conventional now that all the users, especially in the dairy space, is so much H2S and dairy gas that the systems just work and the end users are happy with these. So we're definitely in the realm of conventional now with the Thiopaq, and they just seem to be working. So even though there's a lot of information here, there's a lot of chemistry, it just works. So there you have it. So on to the next.
Yeah, and blame Paul for chemistry. He asked me to be technical, and I love that.
I am to blame. I said these are going to be technophiles on the call here with us, and we want to go deep. So thank you.
I love it. I love it. So I have 10 more minutes, and that's going to be perfect for the next one. Biopack CBD. I want to be very careful when I discuss this technology here. I don't think this is going to be. We're not coming and bringing this as a solution for the CSTR or the lagoon markets. That's absolutely not what this is for, and that's not what Paques is known for, right? Paques, we're more on the technology integration and maybe know-how solutions. And over time, when we were trying to figure out where CBD can fit well in the United States market, and actually Paul was part of this brainstorm, it seems like and this is what I will be presenting it as a focus right now, We believe that this could be quite a good solution for the dairy where they use sand as a bedding. And I'll explain why. So the basic idea, there is no surprise here from the approach. This is, for all intents and purposes, a CSTR flocculant anaerobic digestion. There is no bells and whistles on the hydrolysis, which was a beautiful presentation before me, or any other application for optimization of the digestion itself per se. What's unique about this system, and I'll drill a little bit more into it, is the add-ons that we can add, and we engineer it around the system. And the best add-on that we have is an external hydraulic drive rig system internally to the digester that constantly sweeps the floor into a precast openings that then go into the suction side of recirculation pumps that continuously turn the digester at approximately 2 turns a day. And around that, we can add hydrocyclones or additional settler solution to pre-thicken. Today, I'll mostly concentrate on the hydrocyclones. Let me discuss why. So the basic idea is that you will have a sand-laden manure coming in here. And let's say your HRT is your usual HRT of around 20 days. And at the bottom quarter of the digester, you will take the effluent and take it out and maybe not even necessarily use any thickening technology. But the bottom rake will continuously sweep the floor, and the specific gravity of sand allows the sand to precipitate inside the system much faster. Let's say if the specific gravity of anaerobic sludge is 1 to 1.1, the specific gravity of sand is 2.2 to 2.6. And then we pass it through a hydrocyclone, as I said, at a very high turnover of, let's say, 2 turns a day, which at the 20 HRT inside of the system turns this reactor 40 times. And then through an established hydrocyclones, we separate sand on the continuous basis, which allows the internals of the reactor to stay very, very low concentration on sand, and overall allows you to digest the entirety of the sand laden manure that comes into the system without separating the sand prior to digestion, which could lose you, let's say, 5 to 20% of organics, in which case here, they're all exposed to the digester environment. The mixing is occurred hydraulically, and I said at what power, and the added power is quite substantial. And since it's a uniform and continuous through the top nozzle system, there is the only stratification that occurs is the heavy stratification on the bottom. And we avoid using any heavy solids from the bottom by taking the effluent from the bottom quarter, above the quarter of the system, and avoiding any buildup on the top that is constantly being beaten down with a set of very robust stainless steel nozzles. Here is what I'm talking about, and here's the internals. This is the externally driven hydraulic drive for the system. All you need to do is precast copper openings, and in agricultural facilities, people know this because every single silo you'll ever see will have exactly the same precasts. And all that is on the inside is the moving part with no mechanism on the inside besides the gears. And we guarantee at least 2.5 years of internal operation with no necessity for the access as long as the external drive is maintained. And then the full recirculation of the effluent, whether through hydrocyclone or not, goes over the top, over the nozzles, continuously beating down on the top layer, and allows you a uniform distribution of the plug flow mixing inside of your CSTR. This is relatively new application. There is 18 application worldwide, no pretreatment required, simple operation, great mixing, no mechanical mixing involved, no accumulation of heavy solids, no short circuiting, no scum formation over the top. And the VLR up to 6 kilograms of COD meter cube per day, but that's on case-by-case basis. couple case studies to just show that over the last, especially 10 years, this really starting to take off, and we're starting to bring it in North American market as well. But to show you that there is a continuous operation with a good shown performance around the grit and solids removal as well. So if anyone is wondering for some references, they're fully available here for the full track of well-performing systems. This is a dairy in China with sandbed manure, perfect operation, no VFA build-up, long-term operations, right? I'm not showing you a short-term slides. You see this is 3/1/2019, this is 11. So from March to November, continuous operational data, very steady operations. This one I like to include all the time because people like big installations. Well, I like them too, but this project for the Green Create in the Netherlands, what is this? 12 digesters, and they're going to be installing 12 more. This is chicken manure, and as you know, chicken manure is very heavy on the grid because they literally swallow stones to help them with their digestion. And they specifically chose CBD because handling the stones is quite difficult, and they really liked and appreciated the approach here. We have a pilot available if anyone is not satisfied with the references as is, and there is an opportunity to pilot. Pilot will be made available, bring it to the site fully automated and ready to be installed. To summarize, Thiopaq, as Paul highlighted, this is not an innovative technology. Well, it is innovative in the sense that it was brought in the market from scratch, literally from university research to application by us. At this point, there's over 300 applications in the world, low O&M. And Biopack CBD is our new mechanical, let's say, twist on the conventional CSTR that we do believe is very good with for some very specific niche applications, right? I mean, heavy grid where you have to install above ground tank due to land limitation or whatever it is. So shorter HRT, controlled engineered system where the grid or the sand removal is paramount. I think it's a quite good application for that specific niche. I think I'm right on time, huh, Paul? Not bad.
I think you are right on time. Nice job. Well done. Thank you, Timur. I think both of those technologies are exciting in this time and place.